see there is a wire center from where all the wires runs to different repeaters. The repeaters are adjacent from the adjacent repeaters are at equal distance from each other so that the geometry of the ring is maintained. So it has got a lot of advantage and it resolves this perambulation issue because if any particular repeater fails, that testing can be done easily by launching a signal, by launching a message in the uh, LAN and seeing whether up to which point this message is going. So by that we can uh, identify the faulty repeater and we can bypass this particular area which is faulty, so that the other stations can communicate, right? So the entire communication will not be disrupted. Then the second thing is that any repeater, if you want to add, it can easily be added by running a cable from the wire center, and the length of the cable should be equal between the two adjacent repeaters so that the geometry of the ring is maintained. So those two issues were resolved easily by the this ring wiring concentrator. But the only issue, disadvantage is that it requires a lot of cable and the timing jitter issue is not yet solved. Why we are interested in refining this architecture? We are interested in refining this architecture just because we want to increase the length of our network. So when we are increasing the length of our network, obviously we want to have more number of stations on our network. So when we are talking about that, the timing jitter issue comes and stops that we cannot have a larger network, means a network comprising more number of stations. So how this issue can be resolved? To resolve this issue, once again, what could be the possible solution? The possible solution is to use smaller rings. Smaller rings, when the rings will be small, fault isolation will not be an issue, timing jitter will not be an issue, right? So using smaller rings and connect them through some bridge. So we were discussing about bridge. Bridge is a two-layer device, right, which acts at the physical and the MAC layer of the physical and link layer of the uh, TCP/IP or OSI reference model, right? So it's an intermediate device. It is implemented in software, right? So what is the job of a bridge, right? How does the bridge works? So you can see that. Let me just take it through this, right? So you know that you should also be clear about some of the things, like when we deal with data link layer, we say it as a frame, right? The data link layer performs framing, right? Is it not? The data link layer performs framing. The network layer, when the packet is there, we say it as a datagram, right? And at the transport layer, it is referred to as a segment. Because once it is at network layer, uh, I think I must be having a diagram, that diagram. Okay, that will come later. So similarly, if I talk about addressing part, data link layer we use MAC address, network layer we use a datagram or IP address, transport layer we use a socket address, right? This already we have discussed what is a socket address and how it is obtained, that it is a combination of an IP address plus port number. Port number refers to a particular process running on that particular port on this on the end user, right? End user may be running multiple applications. So port number specifies the type of application running on that port, right? Each application is identified by a port number on that machine. So a combination of IP address and port number gives us a socket address, right? Now, how does the bridge functions? So you should the bridge, as I told you, that bridge is basically a two-layer device. We cannot. First of all, a question arises that why can't we have a single LAN? Why can't we have a single LAN? So I asked you this question last time, I think. Uh, can anyone say why can't we have a larger single LAN, because as I told you that there are some issues when we talk about a single LAN. There is a reliability issue that if a failure will come and will stop everything, then there is a performance issue, as the same bandwidth will be shared by more number of users. As the number of users increases on the network, the performance degrades. Then another issue was the confidentiality or the security of the things, like when you are moving some data, right? When you are on a single network, there are different types of users. There are some intruders. They can also read your data, so your data is vulnerable, right? So to avoid that, like if I want that my data should, which is a confidential data, should not leave this portion of the network. This should only be delivered in a certain portion of the network, not in the entire network. Then that facility is not there when we talk about a single LAN. And then the geographical limitations can also be there, like whether you can lead to a single LAN or not. Suppose the offices of a company are like separated by a highway, right? And you don't have the provision to put a single cable run. So then you can use some sort of a microwave, you can use a Wi-Fi or long distance Wi-Fi that covers a longer distance, or you can use a different sort of schemes. So shorting is LANs are important, right? And when they are separated out by using bridge. So what is the job of a bridge? Bridge basically bridge is a two-layer device. So bridge doesn't add or remove anything in the frame, right? So whatever frames are coming from to a bridge, it simply it checks the destination address and forward that to the other side. So bridge also has got different ports. You can see I have marked 1, 2, 3, 4. So what is the job of a bridge? That if suppose there are two LANs, LAN A and LAN B, and a bridge is connected in between, right? So once the data, this is LAN A, this is LAN B. So any station transmitting from LAN A to a station, suppose station 1 is transmitting to station 10. So that frame should not come to this on this LAN B, right? So once it comes to bridge reads the destination address, because bridge maintains a kind of a routing table, right? They identify that which station is on which side, they know, and accordingly that which station is connected to which port number, right? So they know that this particular station lies on this portion of the LAN, because if it is connected on port number 1, station 10 is also connected on this LAN A. So any messages moving from station 10 to on this LAN, or so it is connected through port number 1. So it identifies when a packet moves from this side. See, this is also they learn. The bridge learns. You will study this part. That we say that adaptive learning. Do you know adaptive learning? Any example? See, it's very simple. Like when we go to any place, suppose we are visiting a place first time, right? When we are visiting a place first time, what we do, if we are unaware of the place, so we go and see the path कि हम लोग यहाँ कैसे जा रहे हैं. Then we notice everything, that these are the landmarks. Okay, so if I am coming next time, I will notice those landmarks. Okay, and then I will reach a particular place. Similarly, how the bridge learns that whether this station 12 is on LAN B or this station 2 is on LAN A. Basically होता क्या है, जब when this station 2 transmits to suppose station 11, station 2 is transmitting to station 11. So station 2 frame comes over here at the bridge, port number 1. So when it checks, the bridge checks the source address, okay, and the destination address. So once it checks the source address, it finds that it is station 2. If I frame from station 2 to station 11, so once station 2 is coming here, right, when the bridge checks the source address, it finds it is station 2. So station 2, because it is a source station and it is destination is station 11, right? So even though it doesn't know about which station is connected on which side initially, in the beginning, bridge has no knowledge about which station is on LAN A, which station is on LAN B, but seeing the source address, it understands that station 2 is on this side, LAN A, and it notes down that station 2 on port number 1. But it is not knowing about station 11. Then what it will do? Anyone? आपने पढ़ा है ये सब? बोलो. Routing techniques पढ़ी है ना? Different routing techniques. तो हम, can you say? कार्तिक राय बता सकते हो, आपने पढ़ा है?
Sir, can you repeat the question again?
I am asking that suppose if you had followed that this bridge station 2 is on this side on port 1, that it knows by seeing the source address of the frame. When station 2 is sending to station 11, so when the frame arrives, it checks the source address and destination address. So once it checks the source address, it understands that station 2 is on port number 1. So that means station 2 is connected on LAN A. But it has no idea about where station 11 is. So what it will do? Bridge has no idea where the station is. So what it will do? You have studied the different routing techniques. Can you name? Can you name? Karthik, I repeated the question.
Sir, routing types are static routing and dynamic
routing. There is a flooding.
Flooding, yes, sir.
So what it will do? It will flood the
Yes,
same
sir.
frame on
network.
all other ports, on all the ports, except the incoming port. In all the ports, it will flood that frame. So it will reach station 11, right? But still it is unaware where exactly station 11 is connected. Then next time, suppose in the future, station 11 transmits something to station 10. So the frame, once the frame reaches through port 2, it checks that the station 11 is the source address and the packet is, the frame is coming at port number 2. So that means station 11 is coming at LAN B. So then it notes down that the station 11 on port number 2. So like that, the bridge adapts learning, right? So what is the job of a bridge? Bridge reads all the frame transmitted on A and accept those addressed to any station on LAN B. स्टेशन ए लैन ए से लैन ए पे ही जाना है तो वो उसको इधर फॉरवर्ड नहीं करेगा. It will forward only those frames which are coming from LAN A and are intended for LAN B. Similarly, it does the same thing for B to A, LAN B to LAN A, right? Bridge makes no modification to the content or format of the frames it receives, okay, nor it encapsulates them in any header. It simply copy a frame and forward it and repeat it with exactly the same bit pattern on the other LAN. And another important thing that you should note, that the bridge interconnects similar LANs. What is the meaning of similar LANs? That both the LANs are using the similar things, like one LAN is suppose Ethernet LAN, the other LAN should also be an Ethernet LAN. It cannot be a FDDI LAN, right? So bridge interconnects similar LANs. Similar LANs means they use the same LAN protocols. So bridge must also have some routing and addressing intelligence, right? So at least it should know that which are the stations connected on LAN A or which are the stations connected on LAN B. So it can connect more than two LANs because as many ports, as many LANs can be connected. So bridge is basically used to provide an extension to the LAN, right? So we will study the protocol architecture and other things later. Okay, so I hope the functionality of a bridge is clear, right? But seeing your response, I should not say, but I just want to mention one thing. See, if you guys were not interested, you should not have taken this paper, because this is mostly the, or if you feel that there is some issue at my side, then you should tell me, I should improve it, right? Otherwise I must tell you that this paper is one paper. It's very interesting, it is very useful for your campus placement, but at the same time I also mentioned that there are maximum number of student fails in this paper also, right? So if you are thinking that like in other courses that कोई एक बंदा करेगा, हम सारे नेट से ढूंढ लेंगे, नेट से कर लेंगे, राइट? वो पॉसिबल नहीं होगा. आप पहला क्विज दोगे, आपको समझ में आ जाएगी वो बात, राइट? ये अगर आप सोच रहे हो कि हम नहीं, एक बंदा करेगा, हम जो है बाकी सारे उसको कॉपी कर लेंगे, सेम चीज जैसा बाकी सब्जेक्ट्स में होता है, वो इस सब्जेक्ट में नहीं हो पाएगा. आप चाहो तो अपने सीनियर से फीडबैक ले लेना, ठीक है? ये भी ऑनलाइन मोड का बात मैं कर रहा हूँ, और अगर ऑफलाइन मोड होगा तो बहुत ही मुश्किल होगा, ठीक है? तो ये बात आप जान के रखना, फिर आप मेरे को बाद में मत बोलना कि सर ऐसा हो गया, हमारा कैरियर स्टेक पे है, हमारा ये सब है, तो फिर हम लोग आपको कोई मदद नहीं कर पाएंगे, राइट? तो जैसे अभी लोग जुड़ते हैं, क्लास में आते हैं, फिर वापस चले जाते हैं, दैट इज नॉट करेक्ट. या हमारा ग्रेड खराब हो रहा है, वी विल बी गेटिंग लेस, grade is not that good, then we will not be able to help you if you guys don't listen to and won't respond. ठीक है? सिंपल आंसर हमें याद नहीं है, we do not remember. The same thing can you reply in a campus interview, and once you ask someone, they will start leaving the class. So what is this? If you are not at all interested, don't come. Those who are interested will come, right? I'm saying this. एक बच्चा भी आएगा, and if he is interested, I will teach, right? You appear directly in the quiz, no issue, and check from the internet how many questions you are able to do, right? So I don't want to say this again, right? I want your support also to finish this course, right? Otherwise it will be very difficult. So we have understood that the bridges can be used for extension of the lens, and bridge performs filtering, right, based on the addresses, source address and destination address. They perform filtering of the frames. They maintain a routing table. In that routing table, they maintain that which particular station is connected to which particular port, right? So they have some routing intelligence, and based on the routing intelligence, they forward the frame, right? They do not modify anything in the frame. They simply copy the frame and regenerate the similar on the other side of the LAN, right? So with this idea, let us go back to our this star ring architecture. So our question was that initially we came from a ring topology to star ring architecture or ring wiring concentrator, because we want to increase the length of the network. At the same time, we uh, we want to reduce the cable requirement also. So what is the solution for that? The solution is this, that we can have rings, right? We can have rings in this form. The bridge, there is a bridge. Bridge will connect. This is one ring, right? Ring wiring concentrator. So this is one ring. You can say node is connected to this ring wiring concentrator, right? And they are connected to bridge. So first of all, the cabling requirement is reduced. Moreover, since they are connected through bridge, uh, they are uh, they are having, like, we can have we can increase the length of the network with more number of stations, right? More number of such sub networks can be connected using this bridge, right? More ring lengths can be connected using this bridge. So the cable length is increased, right? The network length is increased, more number of stations can be there, and at the same time the cable requirement is reduced, right? But what is the disadvantage? Can you say what is the disadvantage? Because if suppose uh, a particular node fails, a particular this fails, then also inter-ring traffic will intra-ring traffic will not be affected, right? If this bridge fails, suppose if this particular bridge fails, right, then also intra-ring traffic will continue, right? And uh, inter-ring traffic will be affected only if the bridge fails. But in this way, the automatic acknowledgement feature of the ring is lost. That is the disadvantage, because now we do not have that automatic acknowledgement feature, because once the frame is launched in the ring, uh, because it is to be passed through the bridge, so who will remove? So that automatic, it doesn't come back to the station. So automatic acknowledgement feature is lost. And if there is a very high inter-ring traffic, then also one bridge will not be able to manage. So in that case, we need to go for a multiple bridges like this, one bridge, another bridge, and through this there will be more number of ring lengths. So like that. There are rings also of different types of rings are there. One is called as a You can see that there is a primary ring, there is a secondary ring. Can you say what is the meaning of primary ring and secondary ring? You can see that this is a bypass state. I told you that the repeater can be either in the listening state, transmitting state, or in a bypass state. So this is a bypass node. So this node, if this node is not working, it can be a bypass node. So it is not participating, right? This node is inserted node. A new node is connected. So the same amount of cable will run. So this is one wiring concentrator. This is a secondary ring. This is a primary ring, right? So like that, we can. This is another wiring concentrator. So this way we can connect multiple rings. So primary ring is like the main tire of your car, right? So if it fails, if the primary मान लो आपका पंक्चर हो गया कार में, then what do? You have an option of stepney, right? So you take out an stepney and put it. So similarly, if suppose this primary ring fails, there is a dual ring. It is also called as a dual ring. So in the dual ring, if the primary ring fails, the secondary ring starts working and start working, right? So once the primary ring is reinstalled, once again the primary ring starts working, right, from the secondary ring. So we can have, we have a higher, if we connect, if we use only a single bridge, right, we can have an issue of, if there is a high inter-ring traffic, means from one ring to another ring, we need to go for a, this bridge will not be able to, single bridge will not be able to manage. So we need to go for multiple bridges, right? So that will be bridge will be connected with another bridge, and multiple rings can be connected with that. So one thing is very clear, that failure of the bridge doesn't prevent intra-ring traffic. Okay, and multiple rings may be employed to obtain a satisfactory level of performance whenever the throughput capability of a single ring is exceeded. Okay, but there are some issues, like the automatic acknowledgement feature of the ring is lost. So who will take care of that? Whether the frame is delivered successfully or not, who will take care of that? It is to be taken care by the higher layer protocols, right? So performance may be affected if there is a high inter-ring traffic. So in that case also the performance will not improve much. We need to minimize inter-ring traffic. We need to concentrate more on intra-ring traffic, right? So this is an example of a ring wiring concentrator, and how we can extend the network using this bridge. Any doubt? So now coming to start topology, I have already told you that there is a header hub, intermediate hub. So this already I have told that this this is a, logically it is a bus, right? So whatever you transmit, whatever station transmit, it goes to the hub, and then hub transmits it on all the outgoing links, right? So this hub can act in a broadcast fashion, so it will transmit on all the links, or it can act as a switch. So now how does this switch works, right? You just read this. In a bus configuration, all stations share capacity of 10 Mbps, right? It's an example of a shared medium bus. So every station is transmitting at 10 Mbps. All other stations are also receiving at 10 Mbps, right? So if we put a hub, right, then also the same thing happens. What will be the throughput for this hub? 10 Mbps it will transmit and 10 Mbps it will receive. So the data transfer will be at a data rate of 10 Mbps, right? But when we use a switch, what will happen? At the same time, A is transmitting to C, B is transmitting to D, because the data, this time the frame will not be broadcasted on all the links. It will be switched to only a destination link. So now if the two stations are simultaneously transmitting, it will be 2 into 10 Mbps. So the throughput will be n into 10 Mbps if n number of stations are transmitting at the same time. So this switch, which we say as a LAN switch, this LAN switch works in two ways. LAN switch is works in the form of a store and forward or cut through switch. So what is store and forward and what is cut through? See, you know about bridge. Bridge के बारे में मैंने आपको क्या बताया? Bridge क्या करता है? Bridge works in the form of store and forward. It simply copies the frame, the incoming frame, then regenerate the same frame on the outgoing link. तो ब्रिज क्या करता है कि ब्रिज, जैसे ये आपका फ्रेम होता है, राइट, आपने पढ़ा होगा द फ्रेम में क्या होता है? सोर्स एड्रेस होता है, डेस्टिनेशन एड्रेस होता है, राइट, देन देयर इज हाउ मेनी डेटा बाइट्स आर देयर, राइट, देन डेटा होता है, देन देयर इज अ सीआरसी मींस if there is error any in the frame to check that. आपने पढ़ा है ना CRC, cyclic redundancy check, right? So this is at the end of the frame. So so when this frame arrives, there are two types of LAN switch, store and forward. So store and forward में क्या होता है? In case of store and forward, it copies the entire frame. Okay, it first copies the entire frame and then checks the source address and destination address, and based on that it checks its routing table, right? They have a routing table, then it checks the routing table and decides that it should be forwarded from which particular port, right? There are multiple ports of a switch, so it will be forwarded through which particular port. So based on the source and destination address, it decides in a store and forward manner. But when I say that it is a cut through switch क्या करता है? This type of switch speeds up the process. How? They simply cut this portion. They simply cut the address portion of the frame. Means cut matlab they only copy they know that the address appears at the beginning of the frame. So they take advantage of the fact that the address is appearing at the beginning of a frame. So they simply copy that address. Unlike copying the whole frame, it copies only the address portion. And once it copies the address portion, so obviously it saves time. Is it not? Once it is copying only the address portion, not the complete frame, so it saves lot of time as compared to the store and forward operation. So obviously it is faster, right? And based on this address only they check their routing table and they forward the frame to the desired port, right? From the desired port. Can you say, if it is so, what is the disadvantage of cut through switch? Anybody? What will be the disadvantage of cut through switch? Suppose like police is checking, Okay, if they are checking only the iCards and they are allowing, they are not checking the what is there inside the bag. Okay, they are only checking your iCard and it is and they are allowing, they are not checking what is there in the bag. So similarly here also in a cut through switch there are chances that they may circulate a bad frame. Bad frame in the sense a corrupted frame, right? Because you can see here they are only copying the beginning of a frame. They are not copying the entire frame. So if they do not copy the entire frame, how will they know that this frame is corrupted or this frame is okay? So because the CRC appears at the end of the frame. So how will they know? Right? So if they are not knowing, so they may circulate a bad frame in the network. So that is a disadvantage with this type of switch, cut through switch. Though they are faster enough as compared to store and forward, but they lacks uh, this issue because they lack in checking the CRC part and result in transmission of bad frames, right? So these are the two type of switches: LAN switch, LAN 2, basically 2-layer switches. Okay, any doubt? So now the next topic is this medium access control. Okay, uh, it should not be media, it should be a medium access control. So regarding Mac, there are two things. I have already discussed this, that where exactly you like to deploy the control, whether it in a centralized manner or decentralized manner, and where, right? So it is greater control means coordination is good, single point of failure. That if the central node fails, everything will go in vain, right? But in a distributed, it is more difficult, more complex to implement, but it is more redundant because if you know only a one path to go, and if there is something uh, some jam on that path, you will not be able to move. But with having knowledge of redundant paths, right? If a one path is blocked, the other path can be chosen. So similarly here also in a distributed network where a distributed control where you have more redundancy. So how can it be applied, synchronous or asynchronous? Because synchronous, because this cannot be a good choice. Synchronous cannot be a good choice because a capacity is dedicated to connection. Maybe you are unaware of the demand of a station. Sometimes it has high demand, sometimes it has no demand. So dedicating a portion of the capacity uh, will lead to a wastage of the bandwidth, right? So the best solution is to go for an asynchronous one where whenever there is a demand or then only the allocation will be done. So it is a dynamic approach. The asynchronous systems, I already told you about these things: round robin, each station given turn to transmit data, reservation, divide the medium into slots. It is good for stream traffic. This is also good for streamy traffic. If all the stations have data, then this round robin system will work fine. Okay, otherwise what will happen? Simply they will pass their turn to the other station. So this is also good for streamy traffic. If all our stations have good data, in contention scheme, all station connected content for time. They are good for busty traffic. That is only stations with smaller data. short sporadic transmission, and they are easy to implement. But this type of scheme fails when they work under heavy load conditions. When you are working in a heavy load condition, there are more number of collision occurs because the stations contend for time with each other, and they result in more number of collision, right? So they collapse under heavy load conditions. So you can see what is a MAC frame handling. MAC layer, as I told you, there is an MAC layer in an IEEE 802 reference model. Basically, why this committee was formed? This committee was formed to provide solution for like earlier what was there, like there were different vendors and there was a monopoly of vendors, right? If you are using one particular product from one vendor, then the entire thing should be from that vendor, right? लेकिन अभी क्या है वैसा नहीं है. So this committee provides a solution that should be unique. Like unique means they said that the Ethernet this should be like this. So they brought all the vendors under one umbrella, like to bring uniformity. अब ऐसा नहीं है कि पेन ड्राइव है, USB drive है, so USB drive only one particular company will make. It is not like that. All can make. The protocol is common, right? Company can be different, but the USB protocol is common. So they brought everyone under one umbrella. Okay, so this reference model says that the OSI model is divided in such a way that the link layer, data link layer is divided into two parts: MAC layer and LLC. Okay. So what is MAC? MAC we are discussing, and LLC. So MAC receives data from the LLC. Okay, because how the flow maintains. When you are transmitting from one user to the other user, the data will be received by the MAC layer from the LLC. So what are the fields in there? There is a MAC control, because the MAC header and MAC trailer is added at the back. There is a destination MAC address, there is a source MAC address. LLC means the user data, what is coming or what LLC protocol is used, right? In that, then CRC at the end to check the frame handling, right? So MAC layer detects error and discards frames. LLC optionally retransmits unsuccessful frames. So we will discuss this in detail. Okay. See, this type of schemes which are suitable only for streamy traffic, reservation and round robin, right? But these schemes are only good enough when all the stations have sufficient data to send. If the stations are not having data, these schemes are not good because it will result in a wastage of bandwidth. So what is our aim? Our aim is to look for the techniques which are bandwidth efficient. So we will be looking for techniques like contention, though there are more chances of collision and these things are not suitable for under heavy load conditions. So we will be looking solution for this contention based scheme, because for heavy load we can use round robin and reservation. So what could be the MAC techniques when we are talking about this contention based schemes? So contention based schemes are good for light and moderate load conditions, right? So and you can see that these are all Aloha. There was a pure Aloha, there was a slotted Aloha, then CSMA, CSMACD, CSMACA, they are all contention based schemes. So I told you that the CSMACD, which is also known as carrier sense multiple access collision detection, this scheme is employed in your Ethernet LAN, right? Um, and CSMACA, it is employed in, it is called as a carrier sense multiple access collision avoidance, and this scheme is employed in your wireless LAN. Okay, so this we will start from the next class because time is over. Okay.